All right, in this video, we're going to write a program to add up the numbers, some ints in an array. Okay, and we want to do that with a recursive method. So let's just take a look at how we might go about doing that. First off, by recursion. So let's just say we had some numbers that look like this, an array. Let's say we had 5, 6, 2, and 3. That's what our array looks like, right? And so one way to do this basically would be to say, okay, what I'm going to do is just take the first number, right, 5 plus, and then I'm going to add it to whatever I get when I add up the rest of the array, right? So that's how you might do it by recursion. Just think about it if, your boss was really, really lazy and says, and your boss's job was to add up these numbers, right, in the array. And so the boss says, hey, well, hey, look, I'll just take care of this first one, number 5, right? And then you go add up these numbers, right? And then when you add up these numbers, just bring that back to me and I'll add the 5 to it, okay? And then you said, hey, okay. And then what you did was, then you just did exactly what your boss did, right? And pulled the 6 off, right? And then said to somebody who you're the supervisor of, hey, you go add up these numbers 2 and 3, and when you get done doing that, right, then I will, whatever you get, I'll just add 6 to that, okay? And then I'll take that number and I'll give it back to the boss. The boss will add 5, and so on and so forth, right? So that's basically the idea of it. If we just add up all the other numbers besides the first one, right, then you can just add the first one to that total, and so on and so forth. So here what I'm doing is, right, taking a problem and expressing it in terms of a sort of a smaller sub-problem here. And again, that's a common thing in recursion. So, all right, so that's the basic idea of it. We're going to peel off the first number and then add, and then we're going to call the recursive function again here to do that and add up a smaller array. So we have a couple of choices on how we want to do that. With an array, right, it's not so easy to lengthen or shorten an array in Java. You can do it, right, but we would have to set up a for loop and do it that way. So, which is kind of a pain to have to do. So what we're going to do is to set up just kind of basically set up a way to keep track of where we are in the array. So we're going to start off at index 0, right, and add the array from index 0 all the way out to the end, okay? And then each time the recursive method calls, we'll kind of move this pointer up a little bit. So we're going to be adding from some index, right? When it's say like 1, we'll be adding from some index on up, okay? So we'll have 2 variables in our recursive method, and that way we have to write a little bit less code, and I'm not worried about having to copy the array and all that stuff, all right? So we're going to have 2 variables. One, that's the array itself when we do this. The other is an int variable that will keep track of what index we're at, okay? All right, so let's go here and make a new class. Let's call it sum array, and a main method. And we will need to write define an array to test with All right, and then add another method, public static. In this case, we want to int for the return value. We want it to be the sum, right, of this. And let's call it sum array. All right, in order to do that, we are going to need the array itself, right? And then we are going to have another int variable that's going to keep track of what index we are currently at, okay? Okay. So first off is the base case, right? In the base case, that would be if we were basically at the very last index, right? So we basically want to add up from the index, right, wherever the index is, out to the very last one, right? So if we were at the very last index, then all we would need to do is just return the last number. So if the index is equal to the array length minus 1, that's the very last index, right? Then what we'll do is just return the very last element of the array. Okay. All right, and then we'll do something else. Before we get into that, let me just add a return statement. And so this will compile. And we can test it out, the base case, as we have it. Okay. So I'm going to go ahead and call this method. I'll do system.out.println. And inside I'm going to call numbers, or sorry, no, sum array. And then I'm going to use the array that we had, numbers. And then I'm going to give it the index of the last element. So that would be 0, 1, 2, 3, 4, 5, all right? And so that should just give us a 6 right here when we run that, if I'm thinking about it correctly. Yeah, okay. So what happens is, actually we can trace through it and you can see, doing Control-Shift-R. When I step into this method here, we can see that the array is here and the index is 5, okay? So here we can see that the int that we got was at the very last index, so it's going to fall right in here. And it's just going to return, right, that very last value, which is a 6, and it gets printed there, okay? So basically the sum of of an array of index or just of length 1 is just the number in there, okay? So that's the base case. All right, now let's start working on the situation where we are not dealing with the base case, right? And so that's if the index is anything else, okay? So if the index is not equal to the very last one, right, then what we want to do is pull off the value at whatever index we're at, right? Whatever the index is. All right, and here we're just assuming that it's a valid index, okay? So this will pull off where, whatever the index is. If the index is 0, well, it's going to pull off the element at index 0. If it's at index 1, it's going to pull off this element right here, okay? All right, and then what we're going to do is call the sum array method again. So this is the recursive call. All right, so we're going to call that again. And this time we are going to increase the index by 1. So wherever the index was at, say we were here, right? We're going to peel that 9 off and then add it to whatever you get when you add these up right here. And then that would peel off this first one, add all these up, right? And so on and so forth, okay? All right, let's test that out and see if we're getting what we want. Let's see, we don't need this here. I don't know why I did that. All right, and then run this. Okay, oh, and we would need to set this index back at 0, okay? So this will start adding up from index 0, and we should get, let's just check it out. So that's 13, 15, 13, 19 it looks like, when we run that, okay? So that looks good. All right, looks like it's working out. All right, so again, our base case, right, we have this index, right, that whatever this index is, it will add from that point, right, to out to the edge of the array. And then if it's the very last index, right, it will just return whatever number is there, right? That's the base case right here. If it's not the very last one, right, we peel off the first number, that's what this is, right, and then add, and then we pass this back to the function so it can add it up. So again, that's like the boss saying, hey, you know, I'll handle the 4, right, you go add all these up and come back to me and tell me what you got, and then I'll just add the 4 to what you have, right? So this is the 4, right, and this is, hey, you go add up all of these others. We'll increase the index by 1, and eventually increasing the index 1 by 1 will eventually get to the last index, and that will trigger the base case, and the recursion will stop. Okay. All right, let's take a look. Let's just trace through this one really quickly again. And again, I'm just going to call this sum, so I don't have as much to write. So let's say we did sum of 492 comma 0, okay? So the first thing, right, it would check and to see if the index is the last one, right? So if, right, and looking at this, it is the index that which we're passed. So in this case, right, it's 0. If that's equal to the length of the array minus 1, right? So the length of the array minus 1 here is 2, okay? So the last index, the index of the 2 is 2, okay? Now that's false, right? So 0 is not equal to 2. So it drops down into the else case, right? In the else case, right, what we're returning is the first number, 4, right, plus sum of 492, that's the array, right? Index in this case is 1, right? We increase the index. So that's what's going on here, right, in the recursive call over here. We peel off the first one, right? In this case it's a 4, and then add, and then we call the function again, pass it the same exact array, we don't do anything with it, and we increase the index by 1, right? So here's where we're at next. All right, that will call the method sum again, right? In this case, we have 492, that index 1, right? Like this. So it will check that if statement again. In this case, the index is 1. The last index, right, is 2. and 1 is not equal to 2, right? So it will again drop into the else case, right? And this time the method call will return the number at the index, which is a 9, right? The number at index 1 plus the sum of the array 492, and then it will increase the index by 1, right? So this time it will be 2. So that method will get called again. In this case it will be 492 2. So this time it will check if, all right, and then the index that got passed to the parameter is 2. The last index is 2. Okay, so it will return whatever is at that last index, which is a 2. Okay, so this 2 right here. I probably should have made this index something else, but whatever. All right, so that 2, right, will get sent back here. And we have 9 plus 2, right? That comes out to be 11. All right, and then this 11, right, will get returned up here. So this will become 4 plus 11, which is 15. All right, and then that will be the answer here on the 15. This method will return, right, 15, which is the sum, right, of the elements in this array. Okay. All right, and so that is it on this particular problem.